Hey everybody, this is Larry. This is day 20 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem and just in general, how you're doing. Okay, today's problem is write in parentheses. And oh yeah, I usually do and solve these live. And so if it doesn't go as smoothly, just fast forward through it. Okay, so given a string as containing just the characters, whatever, determine the input string is valid. Okay, so this is actually I mean, there's a linear time solution for this. This is I don't know how to explain this in a way that isn't a textbooky because I think this is a textbook problem with respect to like grammar parsing and stuff like that. There are different ways to do it, but in this case, and this is stuff that actually comes up or used to maybe like 10 years ago used to be more standard of programming interviews because like language parsing and stuff like that is more common. Nowadays, I don't see it as much, but I could be wrong in that one. So, but it is fundamental enough that I think everyone should practice these kind of problems. So there are a couple of ways to do it. If it's more complicated, you may have to think about you know what's it called, recursive descent or something like that. And there are things that you have to just really learn the literature. But in this case, um, and just these things in general, and sometimes you might not remember all the details because you. What I would try to do is not to learn trivia, but to learn name of algorithms or whatever, but to figure out things for me to kind of like the atoms, if you will, of solving these problems, so that I don't have to remember every problem, right? But in this case, this is very fundamental, as I said, and the invariant is just greedy. Basically, anytime you see a left parent, you that's fine. And every time you see a right parent, always matches the one that's closest to the it matches the closest one to the left that isn't already matched, right? Um, and yeah, this is a good implementation practice. The cannot go way of doing it is using a stack. You could do it implicitly. I'm going to do it explicitly. And let's jump right to it. So there's only three of these things, or six, if you will. Let me copy and paste a little bit. And implementation, there's a lot of ways to do it. Let me see. Maybe I'll do it this way where, open parens. Let's just say set of my editor has auto bracket closing, so that's why it keeps on closing for me. But these are the open ones. Let's see if I have to escape any of it. It doesn't look like it. And then we could do close parens. Is you go to maybe a dictionary, mapping it to the open one. And this is not this. I don't know if this is the best way to do it, but that's the way that I'm playing around with it now. Definitely experiment, kind of, as I said, all this is from memory. And if I do it again, I might do it a different way. And you also sometimes see me have multiple videos because the daily problems I've solved in the past, and sometimes I have different solutions because I don't memorize solutions, and that and especially when you're practicing, feel free to experiment, and it's okay to make mistakes because when you make mistakes and when you're debugging, that's when you figure out like, oh, I had this assumption here that is not true, right? Instead of just memorizing things, you could figure out what these invariants are, which is why I always focus about invariants. But yeah, so now for character in S, if C is in open parens, then we just push it to the stack. Else, else, I just want to figure out if I want to put it in it. But yeah, if C is not in closed parens, meaning if this is not the key in it, like if we have other characters, I guess it only contains these, but I guess it's just good habits to kind of be a little bit defensive. So I'm going to return false. Though this would never happen in theory, assuming the inputs are good. But yeah, and then now we want to see if the top of the stack is equal to the matching one. So yeah, so if the top of the stack is not equal to C or not equal to the closed parens of C. This is more like a mapping. But yeah, then we return false. Otherwise, we pop. And that's pretty much it. At the very end, you're able to go through the entire string. You return true, except for, well, that's not true. There are actually a couple of edge cases that I forget, but this is assuming that this is well formed. But yeah, but this is actually if we have to return the stack of the length as equal to 0, because if the character's left, that means that, like if you have something like, oops, as I said, it auto closes for me, the editor. But yeah, if you have something like this left over, that means that, this is not a valid string because it needs to match. And also conversely, if the stack has nothing on top, then you return false. So this should be good, I think. But let's even when you're confident, you definitely should test stuff. And clearly, I have some thing here. Oh, I have to change that to a list. That's fine. But let me finish copying pasting these. A lot of cases actually. Pretend there's music going and this is a montage. Oh, I meant to fix this. I meant to change this to, oops. Yeah, now it auto completes the thing again. I actually don't like it because I like typing it out because I'm just too used to it. Maybe I'm old school, so the thing doesn't help. I have a typo. This is closed parens. And I used it inconsistently, so let's change that here as well. So some typos, but I think the logic should be mostly right. Let's see if that's true. Don't know why this is a little bit slow. Do I have a while loop somewhere? I don't have any loops somewhere. I mean, I have this for loop, but that's about it. So I think maybe Leetcode is just having issues. Yeah, 36 milliseconds, so Leetcode is just having issues. Let me see if the empty string cases. I think that's the only thing that I might worry about. So let's give it a submit. Yeah, again, and depending on what your algorithm is and what your proposal is, sometimes I get questions about why I don't analyze the complexity before programming it, right? And for this one, to be honest, I knew that this was going to be linear time, and for linear time, I don't even look at the constraints because you can't really look at, if you have a linear time algorithm, it's going to be fast enough for most things, unless you get the sense that they want something better than linear, but even then they can't really force it on competitive. But for interviews, I would maybe think about it a little bit. But because this is linear time, I didn't actually look at the constraint, which is 10 to the 4th. And this is a linear time because for each character that's an S, we do constant number of operations. We either push it on the stack, which is O of 1, and look at the hash table, which is O of 1, or we also do look up hash table or look up the back of the stack, look up hash table. So all of these are O of 1 operations, and you have n of these, so in total it's going to be O of n. And the stack in the worst case will be O of n because if you have open parens, for example, that's just going to be a linear number of them. So yeah, that's pretty much all I have. Like I said, this is fundamentals. I definitely practice things like this. And yeah, let me know what you think. I will see you tomorrow. Bye bye.